Welcome to Unstuck. Today, a token that could burn coins straight out of its own liquidity pool and use that to fake its price and drain the pool. We'll see how an AMM sets a price, how one line breaks it, reproduce the drain live, and fix it. With a simple scales example first, so it's crystal clear. The victim was a fee on transfer token, the kind that takes a cut on every trade. Its burn logic had a subtle bug. Instead of burning the seller's tokens, it burned tokens out of the liquidity pool itself. That one difference let the attacker rewrite the price. First, let's understand how the price even works. Price manipulation sounds abstract, but it's very physical once you see it. A like helps. Here's the mental model. An automated market maker is like a ball and scale holding two piles of coins, here WBNB and the token ADC. The price is just the ratio between the two piles. If there's a huge pile of ADC and a small pile of WBNB, ADC is cheap. But if you could suddenly shrink the ADC pile, AIDC would look rare, and the pool would pay out far too much WBNB for each one. Hold that idea. Real pools keep an internal record of each pile called reserves, and a function named sync updates those reserves to match the pool's actual token balances. That's normally fine, but it means anyone who can change how much IIDC the pool physically holds can move the recorded price just by calling sync. Now look at the bug. Here's the tokens burn function. This line burns AIDC. But from the pair, the liquidity pool, not from the seller. It's destroying coins out of the pool's own pile. And then it calls sync, so the pool's ADC pile shrinks, sync tells the pool believe it, and the recorded price of ADC spikes. The attacker can do this at will, burn the pool's ADC sync, and ADC is now artificially precious. Let's watch the pool get robbed. The flaw in one line, the burn debits the pool instead of the seller, and sync makes the pool trust the deflated reserve. AIDC is now fake expensive, so the attacker swaps a small amount of AIDC and walks away with a large amount of the pool's WBNB. The pool starts balanced, 100 WBNB against 1,000,000 AIDC. The attacker burns 990,000 AIDC out of the pool and sinks. The AIDC reserve collapses to 10,000. Now they swap 10,000 ADC and pull out 50 WBNB. A fair swap would have given them about 1. The pool's WBNB halved in a single move. Step by step, burn most of the pool's ad scene from the pool, call sync, and the reserve crashes from 1,000,000 to 10,000. ADC is now about 100 times overpriced. Swap a little, drain the WBNB, repeat if you like. In the real incident, this pulled about 220 WBNB out of a pancake swap pool. And this is live on Sepolia, not just a local test. We deployed this exact token and verified it on Etherscan, source code verified, exact match. The burn function that reaches into the pool is public for anyone to inspect. Here's the manipulation as a real transaction on Sepolia. The action, execute accumulated burn, destroying the pool's ADC and sinking. The reserve collapses on chain right in front of you. And the drain, a real swap transaction pulling 50 WBNB out of the pool at the faked price. A block explorer you can click through, not a mock. The fix follows one rule. A burn must debit the account that owes it, the seller, never the pool. Here the burn hits the caller's own balance and it never touches the AMM or calls sync, because you can only burn coins you actually hold. You can't shrink the pool, so you can't move the price. Same attacker. Now the burn tries to destroy the pool's ADC, but it comes out of the attacker's own balance and they don't own nearly that much, so it reverts. The reserves stay intact, and a swap of 10,000 ADC returns about 1 WBNB, the fair price. No manipulation, no drain. And the fix on chain as well. The same burn call on the fixed token. Status fail. It can only burn the seller's own coins and there aren't nearly enough, so it reverts. The pool is never touched. Side by side burning from the pool and sinking drains 50 WBNB. Burning from the seller gives a fair 1 WBNB and the pool is safe. The rule to carve in stone. A token must never reach into a liquidity pool's balance or poke its sink. The takeaways. Fee and burn logic should only ever touch the sender and the recipient of a transfer. Never a third party like the pool, never let a token reach into an AMM pair or call its sink. Remember that any price is only as trustworthy as how hard the reserves are to move. If anyone can shift them, the price is a lie. For anything that depends on price, use a time-weighted average or a real oracle, not a single pool's instant reserves. A recap: an AMM prices by the ratio of its reserves, and Sync trusts the pool's real balances. The bug burned AIDC out of the pool and synced faking the price, so a tiny swap drained the WBNB. The fix is simply to burn the seller and never touch the pool. We reproduced both. 50 WBNB drained versus a fair, safe swap. Quick one. If these breakdowns help you write safer contracts, the wallet's on screen and there's a Ko-fi link in the description. Every tip funds the next one. Your turn. We'll comment the hack you want reconstructed next and I'll build it live just like this. If it helped, hit like and subscribe. This was a genericized reconstruction. The lesson, not the names. Thanks for watching and see you in the next one.